Hi, welcome back to my channel. I've made a video on atmospheric pressure. I hope you like it. If you have any doubts, any questions, please comment below so that I can answer all of them. And please do not forget to subscribe, like, and share. It really motivates me to make more videos and content for you all. Let's talk about atmospheric pressure. What is pressure? Pressure is nothing but force per unit area. Then what is atmospheric pressure? Atmospheric pressure is the force exerted by the atmosphere per unit area. For example, if you see in this image, if I consider this as a unit area, then the force exerted by the atmosphere above this unit area is nothing as but atmospheric pressure. Now, this pressure can be exerted on anything, be it someone standing on the earth or an aircraft flying at maybe 10,000 feet. Now, if you see here, for example, if anyone is standing here, so the pressure above this in atmosphere exerting any pressure above this person is also atmospheric pressure. And for example, if an aircraft is flying at a flight level, maybe say 10, which is 10,000 feet, so any amount of molecules or any amount of atmosphere that is above this aircraft is exerting pressure on this aircraft, and this pressure is. So now, how does the air exert pressure? We know that atmosphere is made up of millions of molecules like this in this image, and thus it has the mass. And when the gravity of the earth pulls this mass towards the center of the earth, there is a weight that is experienced. So these all molecules consists of certain amount of weight. So what is weight? The formula is weight is equal to m into g, where m is the mass of the air and g is the force, gravity force, and weight of the air is equal to mass into gravitational force. So this is how the air exerts pressure. Now there are two types of atmospheric pressure. Let's come to that, which is very easy to understand here. So there is one that is static pressure, and then there is another which is dynamic pressure. Now what is the difference? So static pressure, static means still. So when an aircraft is still, it's not moving, it experiences static pressure. So the static pressure is on the aircraft from all the direction. If I am standing here, so from all the direction, that is air around me, is exerting static pressure. And then when the aircraft is, maybe you could say that the aircraft is on the runway, ready, lined up, ready to take off. So all the pressure that is being exerted on this aircraft is static pressure when the aircraft is still, or you could say stationary. That is static pressure. Now what is dynamic pressure? The opposite. So basically it is experienced when the aircraft is moving or anyone is moving. For example, if you would have seen that when you drive a car and you take your hand out of the window, you experience a force in the backward direction that pushes your hand back. That is dynamic pressure. So dynamic pressure comes when the aircraft is moving. So now when aircraft is moving, this pressure in the backward, in the opposite direction of the motion, is dynamic pressure. So basically dynamic is experienced when the aircraft is moving. Aircraft experiences both static and dynamic pressure. So static pressure plus dynamic pressure is equal to total pressure experienced by the aircraft. So dynamic pressure is only experienced when the aircraft is moving, and static pressure is experienced all the time because it's all the air exerting pressure around anyone. It could be an aircraft, it could be a person. So now we need to understand that the pressure on the surface of the earth is not equal, because density, pressure, everything changes. The temperature is changing, the density is changing, and so is the pressure. So it's not equal. So basically now there are areas of high pressure and there are areas of low pressure. Now the areas of high and low pressure depends on the mass of the air above that particular location, and because of this difference we know that winds blow. So what is the concept behind how winds blow is because there is different pressure at different locations, and that results in the blowing of winds. And winds blow in which direction? It blows from a area of high pressure to an area of low pressure, and we will talk about this in detail in the chapter winds. Also, the composition of air exerting the atmospheric pressure is not the same. So molecules are more higher in number near the surface of the earth due to gravity as compared to at the higher altitudes. So for example, if I consider this area above the earth's surface, this is maybe our earth. So due to the gravitational force, the molecules of the air would be closer and more. Like I said, that troposphere consists most of your atmosphere, right? So molecules of the air would be more when it's near to the surface, and as you go higher, that reduces. So now they're far apart. So obviously the pressure felt by an aircraft when the aircraft is on ground will be different as compared to the aircraft when the aircraft is in air, which could be any flight level. We'll take like 101 10,000. So aircraft number 1, and this is aircraft number 2. So aircraft number 1, this experiences higher force because all the molecular force is now on this aircraft 1, whereas when we see aircraft number 2, this experience the force which would be lesser as compared to the aircraft number 1, because the atmospheric pressure decreases as we go higher and higher. Atmospheric pressure will be different at different altitude. Pressure falls as we climb. Atmospheric pressure reduces quickly near the surface of the earth, and that is 1 hectopascal per 27 feet. So this is an important value, and as we go higher, the lapse rate decreases because molecules are less, so the lapse rate is also less. So you could just write this down, that atmospheric pressure reduces quickly near the surface of the earth, and this is the value that's important to note. And as we go higher, that is in altitude, the lapse rate also decreases. So now at 20,000 feet, the lapse rate is 1 hectopascal per 50 feet. Now you go even higher, at 40,000 feet, the lapse rate is now 1 hectopascal per 100 feet. So these are also the questions that might come in an exam. So this is very, very important. Now according to the ISA, of course, we need a standard value like I told you in my previous video. So according to the ISA, which is our international standard atmosphere, the pressure lapse rate is assumed to be 1 hectopascal per 30 feet. Now this is what you will be using for your calculation purpose. This is very, very important to remember. Now what is next is that temperature plays an important role in this pressure lapse rate. Now let us consider 3 different scenarios where there are different temperatures. So let's consider this column for the hot air. This could be 1 hot air. Now we could have a colder air here. This could be a column of, third column of cold air. And there could be a column that is normal air. The temperature is neither cold nor hot. This is normal air. Now what you need to understand is that the cold air is basically, it's heavier. So it sinks. So all your particles that would be there would be closer. Now this is the surface of the earth, for example. Let me change the color for making it easier. So this is the surface of the earth. Now when I talk about the cold air, so cold air, obviously the air sinks when it's cold. So all the particles would be closer to the surface of the earth, right? When I talk about normal air, it would neither be cold nor hot. So it would be like distributed somewhat like that. And when we talk about hot air, now in this case, the air is lighter, so it rises up. So more particles would be on the top as compared to the ones near the ground. Now this is just for your understanding. So let me draw a division here. Maybe let's just say this is your flight level 10,000. I'm sorry, this is your flight level 100. So this is 10,000 feet. Now in this, what you need to know is that, let's consider this as the surface of the earth surface. So if my aircraft is here, or if it's here, or if it's here, so what is the pressure that is being exerted by the atmosphere? Let's consider one molecule to exert 1 hectopascal, right? So here the entire pressure that is being exerted is 6 hectopascal. Here also it is 6 hectopascal, and here is also 6 hectopascal. But now when you reach a flight level 100, that is 10,000 feet, in this particular case, what you need to know is, now here the pressure decreases, of course. Here it is 4 hectopascal, here it is 2 hectopascal, and here there is 0 hectopascal. So what is very, very important to note down here is that, let us consider atmospheric pressure at flight level 100 and this that we have compared. So at the same altitude the pressure is different because of the surface temperature. However, the pressure on the surface is the same. So due to the difference in temperature, the pressure exerted on the aircraft at different altitude is different. Now let's talk about the pressure lapse rate. Cold air pressure lapse rate is more as compared to the one in the hot air. Why? Because molecules in cold air is close to the surface of the earth. So here it went from 6 to 0. Here it went from 6 to 4. So the lapse rate in the cold air, right? So you could just write it down also, or you could just take a screenshot. So pressure lapse rate is higher in cold air, like we just saw above, as compared to hot air. And this is important to understand because this would be used in coming up topics. So this was all about the atmospheric pressure. Thank you for watching my video. I hope you enjoyed it. I hope your concepts regarding the atmospheric pressure are clear. If you have any questions, any doubts, please comment below. I would be more than happy to help you with your doubts. Also, please do not forget to like, subscribe, and share. It really helps and motivates me to create more videos.